Yes, this is a diploma thesis from the Düsseldorf University of Applied Sciences. The student who completed it then posed, well, if you look very closely here, this is a very wide membrane, which also bundles quite significantly in the high frequency range. And that's why you can see these yellow lines here. It contains stabilizers, and the membrane is divided into 3 segments. The middle part really only provides the high frequency range, and the 2 outer segments also provide the deeper frequencies, which are then adjusted again via the horn. Right here on top, you can also see the crossover network, which is part of the diploma thesis that controls these 3 segments.
That means it is an office of 2 frequency ranges.
Right. It's like a coaxial office.
That's awesome. And naturally, he also bundles it so he doesn't go down, nor does he go up.
Exactly. He's already grouping them like that into the raw.
Right, Dad? It can have a thick and good reflection. Exactly. But this membrane is also segmented in the exact opposite way. There you have 3 stacked, 3 segments in the gluteal region, and can then again...
So, vertical, exactly. Radiate vertically, exactly.
This has all been researched, so to speak. So there's already a discotheque in Germany. There, these segmented AMTs are installed, and the line array hangs vertically in a straight line, and yet it's adapted to the room, radiating in a curved pattern, because the individual segments are precisely controlled through DSPs. Brilliant. Even a tweeter is still included. That must be somewhere around 1989, 88 or something like that.
Exactly, no office. Yes, of course, nonsense.
Just gonna say you had square too.
Right.
Now, transmission is absolutely mandatory.
It can descend quite a distance, yes.
And the deepest bass is in my old apartment, living room, long hall, toilet.
It is indeed the deepest toilet. That's exactly right.
At that point, the wavelength was quite sufficient.
That's important, the tweeter, because you want to bring up what interests you.
Yes, that was important to me even then. My brother, who's just in and out, was very vocal. I sat there building an alarm system after high school and before or during my studies, and that's when I got to know the creme de la creme of hi-fi high-end like AMT or the Bron, the Ion Tweeter, and other such exotic concepts. Yeah. So that's what I've always had in my ear, and it has become my benchmark. When this AMT was then presented to me here as a kind of further development.
You didn't think it through at all?
I didn't think about it, and then I just started developing. It became very expensive, but it also became very good.
Cool. Well, if I'm stuck with the royal old god...
Yes, the idea actually was, the idea currently is that it truly revolutionizes stage sound, because afterwards it simply sounds like super loud hi-fi. This has to do with that typical live concert compression driver sound, which is simply inherent to those drivers because metallic domes are always used there. But we've also experienced that one of our customers said he had specified a huge system with a 12-inch AMT from us. So 12 inches is truly a single AMT unit. And it was super loud, distortion free in the demo, but the customers then said, make it louder. And that was really loud.
Yes, but they didn't get it. They didn't understand that it was loud because it didn't hurt them.
And the project, here's the really bitter truth, it wasn't implemented with the AMT because it didn't hurt. That's also dangerous. You can also hear 125 dB if there's no distortion.
Yes, but then don't intervene.
But it still damages your ears nonetheless. You just don't notice it because it's loud without causing any pain. And these people, they were professional rental providers who intended to rent out this sound system with the 12-inch AMT driver inside. They didn't need that. They said, no, we need something that distorts, that hurts. Otherwise, no one will believe us that it's truly loud. The sound is
and the Russians will probably find themselves in a very bad situation if they start using sonic cannons. But they won't just fall to the ground in pain, they'll be spinning around.
And with the wire, ideally, if the wire is truly round, it's 4 infinitely small points. That is, of course, 100%. That was the contact surface here, the contact surface between 2 layers. That is 100%.
And if you lay down such a coil, one that isn't tightly packed, and if it's not properly wound, then it will start to rattle. Yes, it will start to rattle.
In the wire, the direction of flow is the same. This means the magnetic fields generated by two adjacent wires don't touch each other, and they repel. So the wires simply start to vibrate because the current flows through them. And then that's one thing. This means we lose energy in the coil because the wires start to rattle.
The energy is actually needed at the loudspeaker, and most energy is needed for acceleration. When driving a car, when cycling, acceleration is always where the energy goes.
Movement, membrane, detachment.
This means the energy that's now being wasted in the coil is actually missing to truly convey the finest information to the loudspeaker, because for that you really need acceleration. These are small transients. These are very fast movements. So the energy supply to the coil fails, however. That's only one aspect. The other side is that when two conductors, or when a conductor moves in a magnetic field,
it
induces a voltage. That means a microphone is created there because that is the principle of a microphone. It's just, it's then wound onto a coil to amplify the effect. That means
microphone forms there.
Make noise? Exactly, it's feeding back.
No, that means first I lose energy because the device rattles, and then the rattling from the coil is microphonically fed back onto the music signal. So, to distinguish this from other phenomena, I've simply coined macro microphony as a working term, because the macro structure, so
the whole thing as a whole, I see.
The coil as a whole, the capacitor winding as a whole, that is the macro structure that vibrates, and then
look at that thing, he's completely out of control.
Crazy.
Phenomenal.
And always nice for pulling out, for unplugging, but no, they are plugged in.
They're fixed, yeah.
Exactly, so you just
at any time bringing in another one.
Holger will probably come back in and bring another capacitor, a 20 series, a capacitor, right at the start. Oh, there he is.
Hello, my dears. Yes, today we have a tremendous honor. We are here at Mundorf, Raimund Mundorf himself, the founder of the company, has invited us. We're here for a visit, and we've actually already discussed pretty much everything, because we jumped right into the thick of it so quickly. And we've already seen all the amazing coils, the amps, and so much more here that we've almost talked ourselves out already. And Holger's coming, and this is Holger, you work at Mundorf.
Yes, actually R&D, both AMT and now capacitor development, etc.
Cool.
A lot of measurement tech before, now more admin work. How that's so?
Yes, because the team is growing, that's just management is always administration.
Important. Cool. You must, after all, pass on the knowledge you acquire.
Okay. I'm heading back to my work now.
Thanks, Holger. Wow, that's naturally very thin now, so we must be careful.
Exactly. We need to make sure it doesn't pop open.
And not being messed around with.
Then we have here.
Small opening show today.
So I've already got myself a stripe. Conden. That's what this is now. Okay.
Yes. What I've been wondering, as I've been looking into Mundorf a bit, and what really interests me now, is how you first started getting in touch with music.
Well, I mean, there are these two distinct groups of people. There are those, the ones who enjoy measuring things and working with electronics, but they hardly ever listen to any music. And then there's the other group of individuals for whom music holds a much deeper meaning in their lives, a true significance. So, where would you personally categorize yourself? Yeah.
Over there.
Well, bit of both, actually. I was fortunate that at our home we already had hi-fi early on, according to the DN standard back then, and my parents were already quite big classical music fans, you could say. And in the 60s, that was still quite unusual, but we already had about 1.5 meters of LPs.
All the classical music top to bottom. So everything by Bach, Deutsche Grammophon.
Exactly, Deutsche Grammophon and plenty, and whether it's German or Russian or Hungarian, what was that called? Where the dog by the gramophone was listed.
Yeah, right.
Emmy?
Emmy.
Exactly. So we actually truly had.
And I grew up with all this music, and that I must say that was also great because this, especially let's say something like Bach with the order in the music. For me as a child, it was truly like the message from a higher world, you know, with that order. I mean, Bach is also church music. It's no coincidence that.
Yes, but this structure in itself, yes, this order of the music that as almost brings you into a state of pure ecstasy, right? Into such a higher.
Exactly. That as a child there was only order. And that was then completed in the living room because there was a bookshelf where Goethe, Schiller, Lessing, Plato stood. Yes, so that was it was the same message just written down again. And so music already really I mean, there were moments when I was sick and I went to bed, I put on Bach harpsichord concertos on my record player back then, closed my eyes, flew, listening to a harpsichord concerto, everything's fine. Yes, so it had.
That sounds very familiar. Oh yeah. Yeah, it is so. It's really, when you're sick and you really want to make music, then...
Yes. When I was ill, I'd be in the living room. I wasn't in my own room because my room, the children's room, was still unheated back then, so I was allowed to lie in the living room because I was sick in the warmth, and there my father had the old Philips tape recorder NN4418, and there was a reel on it with Dvorak from the New World, you know? Yes, it's from the new version. That's exactly right. And you took that all in as I don't know, a 6-year-old or something. And that's just simple as it's gotten into your blood, right?
Right. Then all was well.
Yeah, that was the stuff. Is it exactly. And that's what happens now. The older you get, the more these things come out. That's awesome. Yeah. Yes, you also have to be careful if you're a hi-fi fanatic. We are all, well, your level of craziness, that's professional, right? So, es ist für mich in my Susanne Astesin.
Yes, he then professionalized, so to speak.
And what I find so nice is you said, I think I read that your brothers actually made speaker systems and built speakers.
That's right.
Because when I built speakers, people hated me, right? And you grew up in a biotope, I believe, where you could truly flourish.
Yes, that's right. So my brother, who was just here briefly, who also made that his profession as a dealer of high quality hi-fi, with many awards also from the press, then as a high quality consulting reference, you know. Mm-hmm. Together with him, I subsequently built many loudspeakers. My first real introduction was my older brother, Werner, who was also very much into hi-fi, had a tremendous Grundig system back then, with huge components set up, and had built his very first kit. So I helped him then, and he pursued it to such an extent that he later continued with electronics as an amateur radio operator. And that was for life, you know. And from him, I basically received my very first electronics kit as a gift, the Cosmos Radio Man, and the first soldering iron, yeah. And then radios were also built, but then sound generators were already being built. Really exciting. So the first steps towards synthesizers, so electronic sound production, just a super exciting topic, right? Then there were many building kits, Fischer Technic, Marklin, all these technical building kits.
My brother has the Philips, sorry for the interruption, the Philips, the EM, or I think 2000, this electronics kit. Yeah, where you had these blue things with springs, where you then put them in.
Yeah. Exactly. My friend had it really bad. It hurt so much. Then it began until this spring, and you.
Yes, exactly.
So Cosmos was definitely
better. Yes.
But I'm quite familiar with both of these kits, and that's exactly how I got started.
Cool. Yes, I understand.
So there were these two things. There was the music, and there was this idea of just building something. Yes, just build something. Whether a cabin in the woods or.
Exactly. That's also.
Machine or. Right, that's also something I think about this kind of craziness in us where we're just driven. We always want to be doing something, like building something or creating something new, you know, not just being handed things on a silver platter, but no, we want to achieve it ourselves. You hear high frequencies more and that interests you. So a little bit.
Well, you know, I mean, these are my first
harpsichord, right?
Exactly. That was that was how I was shaped as a child, as I said, with Bach and harpsichord music and all these the whole orchestra with its many overtones, so that you can really hear timbres. That truly fascinated me, you know. I had, for example, with my own DIY projects, a compression driver from Isophone, but it was very directional. And then there was a guide by Mr. Klinger, which was the Bible back then, the Klinger loudspeakers, and it showed how to build an acoustic lens. He had certain, and I really then shaped these lenses from small aluminum plates and with wooden blocks set the spacing between the plates. So I actually built an acoustic lens for this tweeter.
So it won't clump?
So that it doesn't bundle, exactly. And that had already really fascinated me. And later I was working at my brother's shop and soldered an alarm system there and did all sorts of things during my studies. And I did things like the original AMT. Then the ion tweeter from Mr. Braun. So there were actually all kinds of high quality tweeters, and they simply left a lasting impression in my ear.
But that doesn't mean I don't care about bass.
Okay. Because together with my brother, that was already a big deal. So the standard was somehow the transmission line.
Then
as deep as possible down.
Already deep down.
And then the tweeter that's on top really makes sense.
I need to get back to it. My transmission line's in the cellar.
Super tweeter.
Yes, I got myself Philips AD12100 for the channel. They are so wide. This is quite similar to something like this. Full range speakers, which in the 70s in Tokyo, where these NHK stages are located, they have these stages where the AKB girls dance and sing, and they used monitors with those full range speakers back then from Philips. That's a bit iconic. And I think even with that full range, you'd notice it's a 30 centimeter one. You'd notice something's missing at the top. Completely missing, yeah.
A Mundorf amp would definitely be a perfect complement. As a complement, yes, that would be brilliant.
But this act of doing pause, it makes you feel like you're part of a family. This drive, you want to build something and create something new, Solar?
No, that's a capacitor that's been cut open. Oh, cool. It now only serves as a demonstration piece. So it's no longer for listening, but purely as a display object.
I think your solder can be told by its smell.
That's quite possible. No, I do think so. You see, where we have it manufactured, they naturally have their own specific flux. Everyone has their very own unique formula for that.
Right? You'll smell it now.
I like to use it. So I really, really like to use the Mundorf solder. It works great. I just had the cataract operation on one eye. Now I can, again, now I'm reaching for it again for soldering. Before, that went very badly. Yes, so this is incredibly exciting. We've practically been talking here for a long time, even before we turned the camera on. And now we're already totally soft in the head and don't know what we've talked about or what not. But you all got that the treble is very, very important. Raimund is here. That's your pet project, so to speak.
Yeah, let's say after. So in '85, the company was founded initially just with coils. But he built a lot of speaker cabinets for his friends, and because of that he wound many, many coils. He would then clamp the spool of wire between his feet and then go 1, 2, 3, 4.
Ah, yes.
You could also build a machine then.
That is doable.
Yeah. And that was the beginning.
And the combination of Fischer technique, electronic control. I was very much into digital controls for whatever reason. Probably because I wanted to pull all the strings, control everything, and therefore, so digital control. And I built a machine that is digitally controlled with 2 motors, winding coils,
step motor.
And that's precisely how it's done with all the counting, measuring, and winding.
Cool.
And
that's how the coils came into being, and then you went on to develop coils, Monlauf coils, from a standard coil all the way to the absolute high end. Actually, I should really grab my phone now.
And then, for example, we have here a normal coil, and then where you can see now, this is indeed this, but it's already cast in, isn't it?
It's already fused, otherwise it would fall apart in this zone state.
Falling apart, it would completely fall apart, and you can see that here, the individual wires, the coil winding, that the wires only make contact at 4 specific points.
Right. So if you were to actually visualize it, how circles come into contact, you can clearly see the actual area of contact. It's really quite small.
Theoretically, it's just a pinpoint, and with that, a mechanical construction. Now there's a lot of empty space in between.
Exactly. You can see it nicely here too. You can see here exactly.
Mm-hmm. So even where it's tightly wrapped, air still remains there.
Even there's still some leeway.
And that simply causes the coil to tend to oscillate as soon as current flows through it. That is, as soon as a music signal flows through. That's why the coil is potted, yes, impregnated with a resin, so that the windings can no longer vibrate, or at least vibrate much less.
And I think I even heard from you that it also depends on what kind of resin it is. Is that the same, Hayata?
Well, if you take a very, very hard resin, then you just form a block like with glass. Mm-hmm.
Better again.
With a pronounced resonance frequency, you then have across the entire frequency range essentially a stabilization of the coil, but you do have a resonance peak.
That really hits hard in a truly unpleasant way.
Exactly. Yes, if you now take a more viscoelastic resin, then you might have slightly higher bass vibration, still some residual vibration, but you don't have this resonance peak.
No, yeah. So
you have to decide what you want.
So resonance frequency means that at a specific frequency, for example, 3000 Hertz, it suddenly starts to really rattle and vibrate a lot if the resin is very hard. But you can, of course, have it made more expensively and better. I mean, not necessarily more expensive, but certainly more expensive to manufacture. If you then, instead of the wire...
A copper foil is used, right? So, as you can see, this is a copper foil that's been wound up, which is also cut open here again. And then it's easy to see the foils, in between them is a plastic film for insulation. Yeah. And the foil simply, and in this case a paper, the foil lies 100% on the bottom winding, yes. So where in these circles you have a lot of air between the individual conductors, here you have absolutely no air, but a 100% contact. And that's why this construction is simply mechanically more stable.
Mm-hmm. Absolutely cannot make any rattling noise, can it?
Oh yes, it can also do that, but then again, a great deal less.
Yeah. Yeah, so the individual layers don't rattle. If so, then everything rattles.
We have this here. This is silver, a silver foil. And here we see the very first design that we had. This is plastic film in between, right? And this plastic is also quite tough and elastic, so it dampens this vibration very effectively. It's also already superior to potted coils in terms of vibration. Yes, but there are also other effects that result from this particular trace geometry. If these traces become too wide, you can then imagine that there are
the electrons
that run in a zigzag, right? Or electrons that shoot straight through. Yes. And because of that, suddenly there are runtime differences for the signal. Yes. One also knows this from fiber optic cables that there are actually these reflections at the ends. And what goes straight through, and that creates a reverb. So there are signals that arrive directly, and there are signals that simply take a little longer, and that a customer told me it doesn't sit right. There's so much, there's an artificial ambience on it. And then I first thought, what does he mean? But that's an explanation why this artificial spaciousness could come from, because you simply get different latencies across the width.
That would be even worse, so to speak.
Because it's wider, yes. Now, if you consider, of course, the coils are in the bass range. That might not matter at all again. This is once again a question. Where do you apply it? Yeah. But the first thing to note is it's mechanically a much more stable construction. And yet, despite that, this is the step from the plastic film that's here in between to the paper that's also here in between, and which is then again impregnated in a resin.
Well, I've already... So, if you know the sound of plastic bags, I mean, you're definitely going to...
Yes.
You go shopping and it's a bit windy and you hear a tough, a very dull, muffled flapping. If you listen closely, you'll hear the difference between the plastic film as an insulator and the impregnated paper as an insulator. Because this sound, this specific sound of the plastic film is gone when it's paper.
So it's not like you'd sit there thinking, oh, someone's walking by with a plastic bag.
Yes, I understand.
But if you just know it once...
Yes.
Oh, that's right. There's the plastic wrap.
You'll never get that out. Yeah.
And with the paper, it's just gone then, right? So you can listen to music well with it. That's not the question. But, you know, we're talking here like a wine connoisseur.
Exactly the finest detail.
We talk here.
That's exactly how it is. In reality, yes, these are simply components that are specifically designed for individuals who truly appreciate hi-fi.
Yes, it's about high-end.
It's absolute high-end. And of course, you also want to have the perfect sound that you've always desired, right?
You are also, I believe, exceptionally good in how you handle your clients, because sometimes a client might say something that makes you just think to yourself, he's completely lost his mind now. But if you truly listen to what the client is saying and then take a moment to reflect, right?
Yes, the key word is reflection. So if the phenomenon is there and understandable, then you have to develop a physically sound model for why it can be that way. Yes.
And you trust the client when he says he hears...
I'll believe him first that he's actually listening. Yes. And then I'll post, maybe not every client, but the ones I've known for a while. Naturally, it also gives me a good impression of how sensible and reasonable a person seems and how diligently and conscientiously they perform their job, yes? And but I take it seriously first, even if I have no explanation for it, right? I mean, honestly, who among us has an explanation when you speak into your phone and someone in Tokyo can hear you? Can you explain that in detail? How many people can explain that? How many people can explain what happens when they step into an elevator and actually arrive where they want to go? So the layman cannot explain many things and simply uses it.
Yeah. My vocational school teacher asked me the same thing back then. Explain to me how a computer works, right? And I was like, I can't. What? See, you don't even know how a computer works. And you still don't know how it works today. I'm being completely honest, right? Well, I don't have to know everything, but yeah.
I believe the most important thing is simply if I hear something with my system and I hear there's a difference. And I think that's the most important thing, that you just trust your ears for once, because really I know so many people who hear something and then they told me, I already know this sounds better, but I'll use this because it measures better, even though it sounds like crap, right? So, so I believe the most important thing is that people just listen to their ears and trust that what they're hearing is actually the case, and only then start to think, why is that so? You don't have to discover, like you did, that you get so engrossed in a topic that you actually find the explanations. Is a normal consumer buying a hi-fi system doesn't need to do that.
So that, but it's important to at least trust your ears. That's always the most important thing.
So my brother also used to do that when people came into the store with a test report, and then there was always the heretical question, do you want to read or listen to the box now?
Yes.
That really surprised me when I was in England, for example. There are tiny speaker manufacturers who basically build them in their living rooms. People go there, they listen and say, wow, that sounds authentic, that sounds cool, I'll buy it. Yeah, for me as a German, that was truly an eye-opener, that someone just says, yeah, I heard it, I trust it now, right?
I don't need to read that now. I don't need a safety check, no seal, no test report, but I heard it from him and I trust that, yes, that's how it can be as well.
Yeah, true. If only we're always like that.
Way back when I used to own some really great speakers, specifically these digital correction speakers, I activated this correction feature even though I didn't know how to operate it yet. And suddenly this thing sounded so beautiful, I said to myself, no, that's just nonsense. It's far too beautiful. It must be some kind of trick or something, right? I technically put myself on the wrong track there. Yeah. Because I simply didn't even want to accept that something could sound so incredibly good, just like that.
That reminds me of another story that goes with that, and it's about the time when the Wright brothers were the very first to fly, and right nearby there happened to be a magazine, and they did not report on those very first flight attempts, even though they had seen it.
For them, it was too...
Yeah, that was...
Who'd believe me?
No one would ever believe me. Yeah, didn't you guys report on it? Yeah, no, but no one would have believed us anyway. But they actually saw it. Yeah, that's truly insane.
Yes, amazing.
But let's go back again, just for a moment. We have now seen, okay, the actual vibration, but why is it truly important whether it vibrates or not? Because that is actually the very key to understanding so many things. What happens when a coil like that vibrates, right? A music signal passes through it, right? Well, not through the coil itself anymore, but a music signal passes through the current flowing through the coil, causes it to vibrate if it's not wound tightly and impregnated. That's just how it is.
So when wires are carrying a current, a magnetic field is created. Since all the wires are carrying current in the same direction, the magnetic field is also the same for all of them. They actually repel each other. That means they somehow start to get in motion. Yes.
So it starts to rattle, they rattle, simply put. And what happens is you hear the music through the coil, maybe through the entire crossover, but in a way you really don't want to hear it, namely rattling and distorted. Yes, but the current flowing through capacitors, through coils, causes these components to vibrate. This means you need to put energy into the coil to get it to oscillate. Yes, however, that energy is then missing at the loudspeaker. Yes, and
it's a power hog.
It's an energy drainer. Yes, and that energy is naturally most lacking there. We all know you need energy to accelerate when cycling, when driving. When cycling, you can really see it. Accelerating is strenuous. You need a lot of energy.
Initiate membrane movement.
Right, you need lots of energy.
Power, yes.
And if the energy here is lost, then exactly these quick impulses in the treble, for example,
they just disappear, that's all.
They vanish, yes.
So, that's already the first deformation. And then something happens if you consider it a bit more always where a current carrying conductor moves through relative to a magnetic field. So you have a magnet and a current carrying conductor, and you now push that conductor back and forth within the magnetic field. Then a voltage is induced.
And now in the magnetic field, the conductor is moved back and forth. A voltage is induced there. That's what happens in every dynamo, in every microphone.
The mic noise.
Microphony.
The coil moves, and by being within the magnetic field, it generates electricity. Through this movement, current is induced.
Exactly. One wire oscillates within the magnetic field of the adjacent wire, and this relative movement between the wires themselves is then imprinted as a new signal directly into the existing music signal. And that's all there is to it. So you see, you're essentially creating a crackle, a hiss, a racket here, and that sound is then fed back onto the main music signal, ultimately ending up somewhere at the loudspeaker.
That's right.
Yes, that's the second deformation.
And then it suddenly makes sense why different coil constructions sound different. Yes, so this effect, I've called it macromicrophony, because the macrostructure, so a whole coil, a whole capacitor, all these things vibrate, and that gets microphonically picked up.
Does the entire macro refer to the component as a whole?
Exactly. We could now delve into the wire. What happens in such a crystal lattice? There's a vibration too. I then called that micromicrophony to make these two concepts very clear. One can do something against macromicrophony by intelligently and meaningfully immobilizing the structure, potting, oil impregnation, yes, doing everything to eliminate or dampen this vibrational issue. And then there's also the effect that when a current flows through a crystal lattice, the crystal lattice itself also begins to vibrate.
And this oscillation of the crystal lattice itself is then fed back into the music signal as a very delicate, almost imperceptible sound. But that is actually the explanation why different metals, they each have their own, as if every metal has its own resonance spectrum, why metals sound different.
You're a bit like the Getafix of modern hi-fi, aren't you? Because there are Mundorf wires, you know, various kinds of wires. That's what we wanted to ask you about. We want to build a tube amplifier now, and Mundorf would have the very best wires for that.
Okay.
And I believe that's also the case for you, that you have various things, just like Getafix with his pot, you know, where he stirs everything up, different.
You have experimented with metal alloys there.
So Miraculix is sitting somewhere, I don't know, near Karlsruhe and Pforzheim, where all the metal and precious metal smiths are, right? And they melt these alloys for us and make wires and foils and such things from them.
But actually, here we primarily listen to these foil coils during the development phase in very different mixtures of copper with varying proportions of silver and gold, and found that it makes a difference whether in the 100% copper, 0.1% silver gold is present,
or a single % of silver gold, or absolutely none.
It sounds different each time.
Oh, wow.
I mean, we did notice the differences by pulling out some capacitors, putting others in, and there was an immediate audible difference regardless.
Also silver gold.
I'm off.
Well, but I mean, you know this from the cables, right? I mean, with cables, there are cables where silver is inside, cables where copper with silver and other things. Each one sounds different.
Yes. And the structure, the actual state of the crystal lattice, that also plays a role. So, for example, if you roll or draw metal, like when you're drawing wires from it, or when you're rolling out thin foils, then the materials tend to become harder because of that.
Mm. Yes, and that's why when the thick wire is drawn thinner and thinner, it must be annealed soft again in between, so you can draw it at all.
Mm.
Yes, otherwise it would practically just crumble apart. Yes, that means at times the crystal lattice becomes quite stressed due to the rolling process. It hardens to the point where you have a copper wire that doesn't spring quite like steel, but instead it springs much more like steel.
Mm.
Or a soft annealed wire that really just falls away. So it has absolutely no tension. And that means the crystal lattices are in different states and therefore resonate differently. Wow. Yes, and that is then fed back into the music signal via microphony.
Uh-huh.
Yes, and just like that, you have a physically sound explanation for why different metals resonate differently, and that it's not some kind of voodoo.
Mm-hmm.
So here, I mean, these in.
There was a Japanese man who had a very specific alloy cast for the mouthpieces of his flutes. And then he went to pick it up in person, ding, and he tapped on it and said, "No, this is not my alloy. This is."
He certainly heard that. He heard that it resonates differently than the metal he ordered.
It's important to understand a transverse flute. It's designed so that they have metal, they blow into it, and that particular piece, component is extremely important for the sound of the flute.
That's where the sound is made, and depending on how it vibrates, that's how it sounds. And he had a very precise idea of how this sound should be for his mouthpieces and what alloy he needed to create exactly that sound. Not just the geometry. The geometry is, of course, extremely important, right? How is this reed that vibrates? How is it built? Yes, geometry plays a role, but also the metal.
The alloy too.
So, and then suddenly it's no longer voodoo that different metals
Sound different.
Sounds, yes. Crazy.
So much brilliant information. I'm bleeding.
But I haven't said much yet because I can only listen for now, and I'm still learning at the same time. It's incredibly interesting.
It's always a pleasure listening to you.
Thank you. Yes, really fun.
Just to wrap this up completely, there's beyond that this microphony
Beyond that, there are also many effects in the metal, in the conductor, in the insulator that we won't be discussing right now.
I heard from a really nice, a truly excellent cable specialist who is also very well regarded here in Germany. He said that the insulation also has such a big...
That's so...
What kind of influence it has on how a cable sounds.
Yes, that's how it is. Exactly.
That's totally wild.
Yes.
Because you always have to look, you're dealing with electromagnetic fields. Yes, so there are also moving...
For example, this electromagnetic field can cause shifts in the insulator's atomic lattice. Electrons move in and there are interactions. These interactions through electromagnetism and field forces also affect the music signal.
That then makes sense, what we just heard.
Of course. With the coil, you know that it's encapsulated, and if you pull another insulator or a rubber over it and a conductor, it's similar, it's enclosed.
Yes. I must say one thing about this. My wife, for example, is really quite hardcore. She doesn't believe in any fields, I mean, in the sense of electrical or any other kind of radiation. And we once had someone here who's a very good doser. And he walks through the house with the dowsing rod in his hand and then says, here, And my wife, of course, that's nonsense. And then he took her and gave her the rod and told her, close your eyes and walk 10 meters. So she walked 10 meters with the rod and then the thing swung wildly. My wife, she was just done. She was mentally exhausted that in the exact same spot where it was for him, the dowsing rod also reacted for her exactly there where this earth, I don't know what kind of radiation was there, you know. And because she's a very technical person, she thought, what's this nonsense? Then the device reacted and she was done with it. She just couldn't believe that it was actually true. And then we have these small discs from an Austrian manufacturer. You place them on the floor and then the rod, it was gone, right?
Yes, but exactly the same with the cell phone. So if you now tell someone from the 19th century, here, speak into this, someone in Mexico can hear it, they would react just like your wife.
Yes, that's not going to work.
No, that's just bullshit. That can't be, right? That means there's simply a lack of experience and the understanding of why. And it's also good not to believe everything.
Yeah, but man, I find it important that people are open to just accept whatever, right?
Not everyone can do that, though, can they? It's hard to accept that at first. And for your wife, Sia, the situation you just told, she wouldn't have believed it before.
Yes, but then she was in control and her entire worldview completely shattered.
Yes, and then that's great. After that, you can go out and see what explanatory approaches exist to broaden the worldview.
The body is an antenna and has picked up this radiation that comes from the earth, picked it up, and through these metal rods, it set it in motion, right? Because you hold it like this in your hand, it's like that. You can't turn the metal when you hold it like that. That's not possible, but it moves. And always in the same spot.
Yes, but now we need to really focus a bit.
Let's talk about capacitors. Martin and I, we're building equipment and we've got so many capacitors on our minds, whether we're sleeping, thinking, awake or not. For example, we took a tube amplifier and there was a coupling capacitor, a film coupling capacitor. It was a no-name thing. And this 845, a large tube, is actually an amplifier which is one of the strongest, especially in its attack with classical music. It completely broke down.
So, really, a foil or a film capacitor?
Excuse me, that was just like these yellow ones, the ones that are so squiggly.
But already metallized film?
I assume. It just says that.
So, not a heavy metal film?
No.
The distinction? No, that's so easy.
Something so light, then it was metallized plastic.
Exactly. And then I simply took that one out, and then I put in an Evo Alu oil, and not even silver gold, just a regular Evo Alu oil, and that thing suddenly performs. All of a sudden it has attack, all of a sudden it has power.
I believe he's describing exactly what we just discussed.
Yes, but I have the feeling that the capacitor is an amplifier.
No, he's not an energy sink anymore.
He's not an energy sink now.
That's the point. No? That's the point. No, what we just discussed. The capacitor winding also starts to vibrate and drains the music signal, especially in the attacks. Exactly what you're describing. In the attacks, the energy is gone.
Yes.
Yes.
Totally. Really, like when you think this is an 848 with a 300 beat driver, this thing has 2 times 95 watts, and you've got a transistor with 2 times 10 watts, and that thing blasts you to death. And how can that not work now? How is that possible? And then we put one in Avo Alu oil, and the thing, and we're sitting there, and our tears are rolling.
We didn't record it, sadly, but we sat there looking at each other like, not quite.
All of a sudden, the device performs like a completely different class, and people on the channel have also salted in Mundorf capacitors, and they've reported that the thing now suddenly plays so beautifully, right?
Yes. So one might say, okay, but there isn't much energy in the music signal in the tube amplifier. In the sense that current times voltage, there's no energy, because if the current went into the, then it would be broken. But there are high voltages and there are strong field forces.
Less current, more electrical voltage.
And here we have a capacitor foil, which has been metallized with silver gold. You can't really see the thickness, I don't think. I'm not sure if you can make it out clearly right now. Yes, so in this particular instance, it's 5 or 6 mu thick micrometer. Yes. So the distance between the two capacitor plates after this rotation is 5 or 6 micrometers. And if such high voltages are applied there, 200 volts, 100 volts, or whatever the value may be, then because of this small plate distance, high field forces are generated.
They must then push themselves off.
Right, they attract or repel depending on how they're polarized. But high field forces emerge due to the small gaps between the plates, and then suddenly, in the truest sense of the word, things really get going. But where it doesn't belong, specifically in the capacitor. It really starts to get active. You might think, no, there's no energy. But yes, there is, via the field forces that act upon the capacitor foils, right? And that's why they really begin to operate.
So you could have maneuvered your ear right into the tube amplifier without getting an electric shock.
Yes, make some capacitor music. Then it would be.
Exactly. You could actually do that. You just take a 4 ohm or 8 ohm resistor, connect it to the tube amplifier, and then give it some output power. Then you'll hear in your tube amp where it's making music.
Wow. And everywhere he makes music, there's still room. You could make it better, but that's a really excellent tip. Awesome.
Yes.
Yes, exactly. That's how simple development can be.
That's cool. And wherever this commotion precision loses energy?
The ear, again, the measuring instrument. The ear is again the measuring instrument. Yes, you could theoretically, optically. You also told us something interesting about your development of Amt. For example, we have here.
This very specific high frequency foil.
Okay.
And you mentioned that here visually you also...
Yes, so exactly. Fundamentally, it's primarily a foil transducer. What that means is there's a plastic film, and on this plastic film I actually have the plastic film here still in its completely unfolded state. On the plastic film, you'll find aluminum conductor traces. A sheet of aluminum foil is glued on, and then this circuit trace pattern is etched into it. We actually do that ourselves in our lab here, 15 kilometers outside Cologne, in the Champ Park, because it's not neighbor friendly here.
Yes, suitable for community living, okay. It turned out that way anyway, when we were still doing it right here.
And soft. And then when it's folded, does it look like this here?
When it's folded, this is how it looks. Yes, and these pockets that you can see there, they open and close. Yes, that's how the sound is generated. The advantage is that you can use extremely large membrane foils, which, if you imagine, become very narrow once folded. So you get a lot of membrane surface concentrated into a very small space.
This big one, right?
Exactly, the big one. That's what then goes into our Pro AMTs for stage sound reinforcement.
Yeah, there.
Yes, you can easily imagine if you now take a normal compression driver where perhaps a 2.5 or maybe even just a 1.5 inch diaphragm is attached, then you have a metal dome, which is this big.
Yes,
You have to yell and scream with far too little room.
Exactly, and so it doesn't fly away, it's trapped inside a pressure chamber. That means in front of it, there's an aperture where the sound output is then smaller than the membrane surface, right? That helps then because an air cushion forms in front of the...
I understand.
The builds up in front of the membrane inside the pressure chamber, but...
I wondered why something's in front.
That's gonna...
It's nonsense, right?
Exactly. So the compression chamber ensures that the air becomes a spring, which calms the natural oscillation of the diaphragm in the compression driver. But the air is also compressed and it should simultaneously transmit the sound. This also means that all subtle information reproduced by the loudspeaker must pass through this elastic padding. It's like operating a puppet on rubber strings.
Yes, and you're pulling and the
Exactly, yes, and
Time delayed.
So you then send a high frequency signal to the compression driver. It will somehow come out. Also, the frequency doesn't change either, but the entire fine progression, the whole impulse response, you won't get it really clean anymore through this rubber band, through this air cushion in front of the compression driver. What you do get though is that the metallic diaphragm of the compression driver produces inherent resonances, metallic self-resonances, K3, K5, in abundance. And that's why all concert reproduction sounds so unnatural, right? Because you always hear the self-resonance of these metallic and that's fine because there was no other way to present it. So this compression driver was a brilliant invention. It absolutely has its right to exist. Otherwise, we wouldn't have big stage sound systems. But at the cost that the fine texture over time in the music signal is practically masked, and at the same time this metallic sound is actually a key characteristic of the compression driver at these high levels.
That's why trombones and trumpets as well sound so incredibly cool and powerful with horns.
Okay.
Because metal sounds exactly like metal.
But when we're talking about voices, it's then a completely different situation. Or
Violins, wood, right?
If you think at home is okay there for us, I'm okay because you don't have compression drivers have always improved and they've certainly gotten the distortion somewhat under control, but later on stage where it's really about sound pressure that you wouldn't tolerate in your living room at all.
You bring, yeah.
These systems simply reach their limits and it always sounds metallic. That doesn't matter for a synthesizer since no one knows how it sounds.
Exactly. Yes, that's right. That's true. Yes, that's definitely alien sound.
But if you have the idea of a female voice, especially with voices, yes, we hear voices all the time, at least in the past. Today, perhaps somehow only voices from our phones, then we don't even know anymore how voices sound. But let's assume we grew up in a time where we still learned how natural voices sound, yes, then...
Probably critical.
We'd be very critical, having endless reference material.
That's correct. Yes, that's correct. Yes, that's awesome. Now, Holger has exactly brought up the big one. Now, we're looking at the very same slide here.
Exactly, that is
how big it looks then when it's folded.
Right, you can see it has very deep pockets and very large pockets. This gives it a very deep resonance frequency, allowing it to go down to 800 hertz in the buttock area.
800 hertz? Wow.
Well, and that's also a particularity of at least our AMTs. You can actually operate them right up to the resonant frequency.
Cool, no problems?
Yes, though we have...
Of course, so you cut off earlier.
No, we have pro clients who really set the resonance at 800 hertz, but then rolled off at 24 dB. But until then, yes, steep. And then steep.
Then cool, okay.
And that works with these membranes. Cool. It won't break it. Eventually it might not sound pleasant, but up to the resonance frequency, that's fine, yeah.
The rear stabilizers are back.
Yes, here there are none. Not yet any glued on it. Here only the marks are already placed, indicating where the stabilization needs to be attached.
We'll see them there then. Are they on the side or do they come from above? No, you can see it right here. Here you can see two stabilizers at the front, exactly. Yes, and at the back they're a little bit diagonal, and you now have a method to observe how they're swinging.
Yes, we have. That's a tone generator with one that also drives a strobe light. So you exactly, you just have to turn on an LED, a very simple kit. And I don't know if anyone recognized it, but very helpful for such developments because you use the tone generator to make the membrane vibrate. You can also do it with the bass or whatever you want to look at. And the LSD, the LSD, the LED.
This, by the way, is from the vegetable group leek, celery, and dill LSD.
Ah, yes, that makes perfect sense to me.
The LED. Hold on, I'm being taken out.
Excuse me.
Yeah, the LED, you know it, of course, from a stroboscope. At the disco, you only see it like, flash, a flash, a flash. And if that's used correctly in the proper temporal relationship, then you see the vibration of the membrane almost in slow motion, and you then see, for example, how standing waves form across the length, or where the waves then bounce off the rigid frame and are reflected back. Yeah, like that, right? That's how you can also simply optimize the geometry of membranes, right?
Cool.
This Klippel system then offers other ways to laser scan it to see how the resonances and movements are, but it's always about making it visible. Klippel is great, but for amateurs it's naturally far too expensive. And depending on the situation with a stroboscope, you can actually see quite a lot in such a case, yes.
And understand what occurs.
Why indeed? You can see it.
Cool.
And
that's what truly fascinates me, you know. And then you're there, you just like... you just keep digging deeper and deeper, don't you? And you really, really want to know it. And
well, okay, I have the chance now. I really have the chance now to put everything I've collected in 40 years together in 1 hour. Then that's a lot, of course, no? But it's also something that just developed over the years. I know when we got this AMT, when I really because I find the AMT sound simply great, and I often don't find the sound at live concerts to be that good. Yes, I remember I drove to Aachen back then, Chick Corea, Gary Burton, Chick Corea and Gary Burton on vibraphone and classical acoustic piano, right? And that already sounded really good at our place on the self-built systems.
And I make my way to Aachen, I buy myself tickets, I drive to Aachen, I sit down there, then there's some kind of...
a plant with a pile driver, it rattles and clanks, and you think, why, what the hell, why would I go there? Well, no, now you have the actual one standing right in front of you. And it rattles, and it crashes, and it shatters.
Yeah. Oh my goodness gracious.
Sounds better than at home then.
Instruments, and it sounds better at home. So I know people who say I don't go to concerts because they always sound so bad, especially with jazz concerts. And then there are the commentators who now I was also here at the Cologne Arena, watched Udo Lindenberg, great show. But there are 3 brass players, 4 brass players, all sorts of musicians, and all you hear is Udo Lindenberg and the drums because everything else just gets lost. It's
that kind of thing makes me furious. I can't stand it. There I get because I love brass. Brass is so beautiful, and if that's destroyed, there I have to intervene. You know.
Yes, and despite that, you'll get reports afterwards, and people say they don't know any different, right? And they'll say, yeah, it was a super event. Also, of course, seeing Udo live and the entire show, everything's great. But when it's truly about something like jazz or similar, where sound is key, yes, about enjoying music, not just watching a show, then it becomes difficult when it's distorted. And what kind of chance do you have then as a consumer? Are you going to go to the bouncer and say, but that sounds...
Yeah, then he must have...
We really have no idea how the show was.
There is no lobby.
And that's where you then build these professional instruments which are now hanging in the Royal Albert Hall.
They were hanging, right? Well, the idea is, that was, you see, L acoustics, back then, L probably even stands for line array. So because of that, they really became big.
For those who don't know, in a line array is when you take the same type of loudspeaker and stack them more and more one on top of the other. So if you place 20 speakers on top of each other, they form a line. And array means to arrange them, to put them together.
Exactly. So basically, everyone who's ever been to a concert knows them. On every stage, there are always these, let's say, these bananas, these mid-high frequency units stacked one on top of the other and a bit curved at the front, so they project downwards towards the audience.
And the underlying idea here is the larger a membrane gets, in this specific instance where the line is being vertically extended, you see, the more it focuses the sound.
Right? And that's the point. At a concert like this, you don't want to blast the ceiling and not the floor, right? You want to blast the audience.
Exactly. One way, not down, not up.
Exactly. And if I simply extend the membrane surface, then I have a linear membrane, and then the longer it gets, essentially, what happens with the sound beam, right? It becomes more and more focused. And that's what you want to achieve with a line array.
On stage, yes.
On the stage, you see? And that's why they're positioned everywhere, so they can project deeply into the audience. However, we now face the issue once more in the high frequency range. Compression drivers with their small diaphragms are anything but a true line source.
It's a single point source.
It's a point source, you see. You need to install something in front of it, a sound guide to effectively reshape the sound from that point source so that it will then operate just like a line. And
these are the funnels that still stand up.
Exactly. And then L Acoustics, let's just say, had patented the only arrangement that was reasonably functional for such a waveguide. Yeah. And it works reasonably well, so that a nearly line source sound wave, a cylindrical wave as it's called, is then radiated but with considerable effort. And the simple idea behind the AMT is that it's already line shaped.
That is perfect.
That's perfect. And with the large membrane surface, you have an incredibly strong coupling to the air, right? That's called the radiation resistance, right? The coupling to the air, because so much air is directly set in motion within the membrane, at the membrane, the coupling to the air is really good, right? So that's
I have more surface area to set the air in motion. So if I have a small thing that really has to push its way in to generate the same amount of movement in the air.
Exactly. If you calculate how much this diaphragm needs to move to achieve the same sound pressure as a small 2.5-inch dome in a compression driver, the 2.5-inch dome is much more displaced, moved back and forth, yes, than this large surface, so there's much less movement.
Play more relaxed.
It plays in a more relaxed way, and the membrane itself is made of plastic material, which doesn't rattle anywhere near as much as the metal dome.
The metal channel, right? That is for the people who will then much more later to be so much better.
And that is the reason why the ANT unit also produces distortions from a certain signal level, but when it actually produces distortion, it primarily generates K2 distortion.
So, an octave.
Yeah, okay.
And anyone who's ever struck a note on a piano and then exactly the octave knows it's not that easy to figure out, did I just hit the low C or is the other person, if I don't see them, right? Am I just hearing the low note, or are they also playing the octave with it right now? Well, yes, that's because the octave simply appears in the overtone spectrum. Yes, it might sound a bit fuller, but for a layman, it's really hard to tell if someone plays a C4 and a C5 at the same time, or just a C4.
And that is a beautiful sound. That's a sound that is harmonious. It makes me happy and it doesn't hurt me.
Exactly. That's the big advantage with the ANT. If it produces distortion, then it's only K2, only octaves, and it simply does not produce K3 or K5. Yes, and that's why it's perfectly suited for high quality stages once more.
Well, we'd almost have to equip our Philips AD12100 with a Mundorf wide baffles because 30 centimeters wide, like from the 70s.
Yes. If it's really broadly applicable,
he also needs a tweeter. He needs a tweeter.
Then I would do the experiment and hear a small coaxial tweeter. So for the sit in the middle.
Cool.
Then you will have to with the runtime difference. Because the acoustic center in a cone speaker is usually where the voice coil is. That's why.
Right. You'd actually have to
you need to align the magnets.
Exactly. So if it's on a box, it needs to be placed a bit further back. If you now put it for...
Go!
Do you control it digitally? If its digital setting is off, because I naturally cannot advocate for it in any way.
Never ever.
Yeah, or you build, then I'm very much in favor of a passive one that also exists, passive time shifting, because then you need countless components in there, but then
if it's over, the sound is gone.
Exactly, that's the thing, it's difficult.
Then I'd rather set it back a bit higher.
Okay, then it doesn't go coaxially at that point.
Yes.
Unlike in the diploma thesis.
Yes, that's absolutely right. That's
right.
Where it pause. Well, it's just truly, truly beautiful.
So, as I said, tweeters, harpsichord, concerts, the overtone spectrum is simply so important to me because it creates spaciousness. Space is created through fine spatial information, through reverberation. That creates spaciousness. The impression, yes, I have room, I can breathe. Yes, and this information about spaciousness and reverberation, it just gets lost with these PE sound systems because they don't reproduce these fine structures.
But it's like the earlier ones, for example, the very first 44.1 kilohertz CDs and such, they cut off at 20 kilohertz. So much gets lost there, especially the spatial information, overtones. I just love tape recorders.
Yes.
And my large Philips tape recorder, I used a measuring device, a tone generator in and out of it, and 38 kilohertz, no problem at all. It came back with perhaps 2 decibels of loss.
38 kilohertz. But unfortunately, I haven't found a band they can record with now.
I want to record. I have the tape deck.
Yes, but I believe that consciousness to some extent somehow returns again. So that
analog recording, yes, that's really in now where recording studios have analog tape machines. Yes, they are gathering all the old stuff again so they can make it sound like it used to.
Yes.
There's a YouTube channel by an Italian guy. He's really nice. It's called Analog Dialogue, and he focuses a lot on those kinds of things. And he once, for example, in a story, featured recording material from Pink Floyd. I think it was Money, and he included sound files from the original pressing, from the master tape, from the first CD, and from the cassette.
And you can, through this high-res, I mean, the sound file up to like 100, 200 kilohertz, you can hear how different they sound.
Pink Floyd. Pink Floyd is, of course, still an ideal example for the AMT because Pink Floyd already back then used AMTs, and actually this original AMT, which was actually developed for hi-fi.
It's from Oscar.
From Oscar Heil, yes, and the ESS Heil AMT, but they solved the problem that hi-fi AMT naturally couldn't handle much power simply by assembling these units by the square meter into iris arrays. So that's something only Pink Floyd would do, who always placed the highest value on sound and who also experimented with quadraphony and such things.
And that's just the way it is, right?
Yes, exactly. Those who could afford it and who thought it was worth it, So they already used the AMT, the original AMT, for stage sound. And probably because they heard it, because they simply wanted it.
Yes, no. But that's the thing is, I have to say, I generally find when it comes to Pink Floyd, what's his name?
Alan Wood?
David Gilmour. Thank you. David Gilmour.
They'd be overheard.
Yes, that's nice. Thank you, Holger. David Gilmour. David Gilmour, I believe, is the audiophile among them. I think David Gilmour's the one, because I saw an interview where he said he still has the old setup they used for mixing, right? So he kept the speakers too, right? He still uses them today, right? I also have many speakers, and it's always a temptation. So now we've already got a lot, which for us personally speaking, we are currently building amplifiers, and we actually have capacitors. And with capacitors, we've really discovered how much you can influence the sound. And you've just told us how metals can sound very different.
And that's why it's also the case that all these film capacitors, which are more commonly used as coupling capacitors between the tubes at the input, at the output. Here, with these capacitors, I can influence an incredible amount regarding the sound, or let's just say even rescue it. My personal opinion is that these components actually do nothing more than affect the bandwidth of the incoming signal. The information is already present there. And now the common misconception people have is that if they put in this capacitor or that one, and then it suddenly sounds more brighter or has more bass, they believe it's actually adding something to the mix. But I believe, no, it simply shows with it the least is lost. The signal...
Yes, ideally nothing is lost and nothing is added.
Correct?
Yes.
Can a capacitor add something? Possible?
Yes, only static.
Background noise. It is, after all, a passive component. So there's no energy being generated.
No energy also comes from the wall socket. But in the ideal scenario, energy is simply just passed along.
Exactly.
Or indeed, in the less than ideal case, induced by vibration or hindered, yes?
Exactly.
And I simply believe that when such a really great capacitor, even if it has silver, gold or not, that it's simply I'll call it bandwidth for myself now. People then scold me in the comment sections because bandwidth technically means something completely different. But I am of the opinion, for me, right now here on Hi-Fi Talk, on the first channel, is a capacitor that truly, when I install it into the amplifier and suddenly I find the soundstage becomes more precise, bigger, wider, I've got more deep bass, I hear more details, then I'd say. For me, it simply offers a wider range because the signal just comes through more, you know? That is actually quite important for us, and we try out so many different capacitors. And every single time when we are at the Phonopre, for example, when we have the Mundorf ones in there, we just feel at home, don't we, Martin?
Yes, that's certainly true.
Absolutely. So this is simply that sound from Mundorf. It's truly and above all affordable, right? Because nowadays some people are already in crazy price territory.
Well, we also concern ourselves with Gagaland out of pure sporting ambition, but fundamentally, the engineering challenge, of course, is simply to be able to produce the best price-performance ratio in every single price segment.
Yeah, I mean, building the world's fastest car is a challenge, but to say I'm building a car for 5,000 euros that's truly outstandingly good, that's just as much of an achievement.
Yes, that would be a very, very significant feature, yes.
And so, you know, for every single price range, you can say, from our perspective, this is simply the best you can build within that price range. And naturally, it's the case that if you're restricted by price categories, then you might have to optimize in a certain direction. Yeah. So I can't put the best transmission, the best seats, the best brakes, and the best engine into a 5,000 euro car. The 5,000 euros simply won't allow for that, indeed. But naturally, I understand that depending on the specific application, the seats might be a little more crucial than the engine. So I then simply have to make decisions about which direction I want to optimize in, and that's something you can adopt. That's why, in the end, you'll find that within a particular price segment, there are actually various different designs. Yes, if you were to construct the absolute ideal capacitor at the very top, there would then only be one single version, at least when it comes to macro microphony.
The entire component.
That's where the whole component oscillates and has inductance, residual inductance. Because it's like this, we say, okay, the capacitor has capacitance, the coil has inductance, the resistor has resistance. But in reality, every wire has inductance. And every single wire possesses a certain resistance. And if you look at it very, very closely, every wire also has a capacitance, which means, to say a capacitor only has capacitance is an ideal state. In the end, a capacitor also has residual inductance. Yes, and depending on residual inductance, if we take an electrolytic, a bipolar one, yes, there is aluminum foil wound up, which is insulated with paper, and it then has 3 or 4 terminals on this aluminum winding. That means with a bipolar electrolytic capacitor, let's say about 10 microfarads, 20 microfarads, there are now 100 or 200 turns, and 4 small tabs are led out from these turns.
And between the 4 flags are the current really must pass through this coil.
Finished.
Yes, what that means is an electrolytic capacitor, even a bipolar one for a crossover network, has a truly audible, measurable inductive component.
Yes.
It's logical, it's wrapped up.
It's wound,
Yes.
right? And here, if you look at it now, here, a film capacitor, there's this thin plastic film, which we just saw earlier, with the 2 metal layers that are...
With only microns, just a few microns thick, yes. So extremely thin.
That one, it is wound up here. This end phase contacting right here. Yes, it is now on one side with one metal coating and on the other side with the other metal coating.
Exactly, they are like one has nothing on one side and the other nothing on the other side.
Exactly, that's what's called the free margin. So one film is metallized from here to about 3 millimeters before this end, and the other one is exactly the opposite.
Metallized. So here I've then let out a plate, and there I've let out a plate. If you consider that, then this end phase contacting is everywhere all around connected to this wound surface, no?
That's why it's so low inductive, or so very low inductive compared to an electrolytic capacitor, where on this you could now on the very same winding with a modern winding machine perhaps place 6, perhaps even 8 solder lugs.
Yes.
Where it is brought out, and between these solder tabs, and for cost reasons sometimes there's just one solder tab and the rest is simply the coil winding.
Yes, and then you have a massive coil.
Right. Then in the bipolar electrolytic capacitor or in the power supplies capacitor, depending on how many contacts are attached, you have a more or less large residual inductance.
But you don't want that.
You don't want that, and it also audibly affects the high frequency range. That's why there used to be car hi-fi crossovers. An electrolytic capacitor was deliberately placed in the high frequency range so the tweeters wouldn't overplay, wouldn't sound harsh, and wouldn't get damaged quickly. So you simply have to know what you're doing, then you can apply it profitably and use it here, but that's not your goal. You want the space, the overtones, and the fine structures.
Exactly.
And then it's about how fast it is.
I also wanted to say something because I've been sitting here I'm listening very intently. I don't say much because I'm really just listening. And we're building our phonoprey here, and we're actually already done. And now, about 2 months ago, I told Jürgen again, hey, listen, I'd really like to try out a few other capacitors.
And we have just gotten in contact, more or less.
Exactly. I would like to try something else again because I was at a friend's, and he also had a phonoprey. We then compared mine with his. Then with this phonoprey, I noticed that in certain aspects, sonically, they were quite similar. We were already impressed, but his was more vibrant. It was quicker. Yeah, you heard the guitar string, that distinct bling-bling sound. And with mine, it was present too, but to a lesser extent. So I just thought, what exactly is this? Well, damn it, I want that too. And then we just compared and identified the components, and I thought I'd really like to try out some other capacitors.
PSU.
Because I think the power supply is probably too slow, so it's not responsive enough. Can't deliver the current quickly. And then we got in contact, or rather Jürgen did, and then we tried them out, and I was completely blown away. I was like, no, that just can't be true.
Just the power unit, just the supply.
Yes, that can't be. Yeah. And I mean, the capacitors that were in there before weren't bad either, but
that was good.
But you were also completely devastated.
Yes, I spent 2 months researching all sorts of manufacturers, and there are things you just gain experience with, and then there are things you somehow have to work out for yourself, and you can't really do anything else but scour the internet and gather people's opinions, and then you just try this one out, and then that one, and then that one's no longer around. He was dead.
Right.
Yeah. And then Martin said to me, hey, listen closely. And for example, we had this particular option that we could also bypass the electrolytic capacitors with film capacitors, like 0.1 nanofarad, 100 nanofarads to bypass the microphone. And that immediately...
Yes.
Really right this very instant. Wow.
Yes.
So not really, a blind test, but immediately a proper step forward.
Oh, exactly.
No need for them.
Not for them.
For those, they are just so good on their own. You can add to them or take away. You truly don't need anything more. Well, you've actually already explained it quite well. You've essentially explained that the film capacitors are located here on the front end, while the electrolytic capacitors, they have tabs.
Exactly, because there's real aluminum foil in there. Basically, an electrolytic capacitor actually looks, right now we only have broken coils lying around here. Basically, an electrolytic capacitor is also, that's just in this case, an aluminum foil. Passes those that are constructed with paper in between, so 2 aluminum foils with 2 layers of paper in between, and then they are soaked with an electrolyte. Right, that's the basic structure. The electrolyte causes aluminum oxide to form on the aluminum as an insulator. Right, so
let's hope they don't short circuit.
Right. And this self-healing function.
No, the self-healing, no, it's just, it reacts more sensitively if you connect it with reverse polarity, meaning plus and minus are swapped, because then this aluminum oxide layer disintegrates, and then the insulation is gone. That's why you mustn't reverse its polarity. And with bipolar electrolytics, you solve that by connecting 2 in series, both with their positive or negative terminals connected together. That means always during one half cycle, one layer gets a little damaged while the other is protected. Exactly, it's constantly being rocked back and forth, and it always regenerates immediately.
That way it holds up in the end, yes.
Nice.
But if one is permanently connected with reversed polarity, then the aluminum oxide layer breaks down, and then then it'll blow up in your face with a loud bang. So where exactly were we now? Oh, right, that's it.
Difference between electrolytic and film caps.
Exactly, you get so you really have to connect to this foil, to this aluminum foil. You really have to connections.
Connect them.
Yes, you wrap the aluminum foil, stop, attach a connector, wrap again, stop the machine, attach the next solder tab. That's what it's called, right? The next solder tab on, then the winding is done. Then a few solder wires stick out from the top of the winding. They're somehow welded underneath the lid, and then you have either 1 contact or 10 contacts or 12 contacts, right? But that must be clear to you. You have to, each time for every single one of these solder tabs you have to stop the winding machine every time.
Just completely stop.
Yeah, that's...
Accelerating, braking, stopping, welding, accelerating, braking, stopping, welding. So every single contact costs production time, right?
Yes. That's very, very complex.
And thus, if you don't tell the manufacturer, add as many contacts as possible, he'll likely add fewer contacts just to save on production time. Huh? So, for not.
You must watch him closely and demand, I want it done exactly like this.
Exactly, that's precisely what we do, especially with these components. We also work with manufacturers on these complex components, examining their production methods. We know how each production method affects the sound. And then they actually provide the construction blueprint. Yes, that's what it is.
We also learned from customers who told us, in the past there was a capacitor from Siemens or Röderstein or something that sounded superb. And we then try to find out,
how come? Why? We cut one open, look inside, and they did it differently. So, and that's how we learned a lot.
Cool. Yeah, that's the thing. I noticed that in our automotive industry, my family in China, they manufacture rubber. And sometimes it's like that, for example, with spring seats in Germany, there's nobody left who with the last one who retired.
Gone. The knowledge is gone.
Yes, that's so.
And then they tell us, you've got the hard rubber spring seat, the way you make it, it's top. And you can't get it in Germany now. It's lost, right? That's sad, yeah, right? You're then pioneers of capacitor construction.
Yeah.
So a little bit of an archaeologist down in the pyramid, right?
Yes, exactly. That's super awesome.
And a little bit of get a fix.
Some get a fix. During the mixing of patented alloys.
Yes, that was exactly. That was also a challenge for our patent attorney to make it clear to the patent examiner that different alloys sound different. We also really had to provide listening reports. These listening reports are included in the patent application.
Yeah, I imagine that's annoying if you then have to do that too, right? for a patent. Like the
Marty now wanted to register that for Red Bull, a patent for an energy drink, didn't he?
Yes.
Yeah. So what do you want?
But it did work. It really worked.
All right.
So we definitely want to get some advice from you, from all of you, when we're building that tube amplifier in the channel, which I saw that Angelique, I think, is what this cable is called, right?
Mm-hmm. Yes, exactly. This is that patented copper, silver, gold alloy, where in this particular copper there's 0.1% silver gold. So that's 0.03% gold and 0.07% silver.
It's in the patent.
Inside. Readable.
You can read it. And you mustn't replicate it.
Exactly. Then you get a slap on the wrist.
And it really does make a difference.
Mm-hmm.
Yes, it does. And we heard it here. And we found out that more is more isn't always true in this situation. You can also put too much of it in, right? Then it changes. I mean, then it just doesn't sound good anymore. It sounds rather tight and edgy. So there were a lot of effects depending on the mixing ratio. And if you say, 0.1%, that can't make a difference, then I'd like to remind you of the 0.8 per mil at this point.
An example from practical life that also
blood alcohol.
That even 1 per mil can make a significant difference. Yes.
Well, for example, we have too much silver at our place. So personally, I don't really like to use silver cables.
Mm-hmm. What's the reason for that?
Yes, because it's simply, I don't feel that this is still the right signal, that it's authentic. I feel it's too bright for me. It's actually softer, but at the same time, it's brighter with the cinch cable now. So a connecting cable between devices. And then you simply say, no, I'd much rather stick with my familiar good copper cable that I already know, and that works perfectly fine. Why? But the real issue is that with hi-fi setups, there are people who have speakers that alter things to such a great extent. Then you have an amplifier that influences this sound in its own particular way. And then you've got that, and then of course I'll have to mix it with the cable again. It's like when I'm, should I take soy, should I take salt, it'll just be too much, then I'll have even more, and with that, so I don't want to get involved. So we try to build amplifiers that are single-ended, class A, with as few components as possible to stay true to the original, to keep it close to the source, because eventually you get bogged down. If you have so many influences, eventually you don't even know what you're doing anymore, right?
That is absolutely the situation. Yes.
Our philosophy.
Yeah, you can.
Less is more. Less is more. That's absolutely right.
And changes, however curious you may be, or you simply have to do it step by step, one change after another. Otherwise, you'll never know what comes from where.
Right. That sounds so familiar to me. Don't put that capacitor in there. Don't do everything. You'd better start with this one. Yeah. That's, yeah. And then higher. Whereas we are now, you're a professional, we're amateurs in that regard, because we're just listening to how this capacitor sounds, how that one sounds, while we're the cooks, you're the carrots.
That's right.
That's why he can say rather little about cooking recipes. I know, of course, fundamentally, because as I said, I'm a Cosmos radio man. I also tried my hand at building amateur radio amplifiers and synthesizers. So I know electronic circuits, and I know, of course, the importance of components in certain places. Yes, but I'm not the amplifier circuit guru.
Yes.
That's a whole science in itself, really. But it's very clear what the power supply simply cannot provide. The amplifier stage cannot possibly save afterwards. That's just the way it is.
Well, many years ago, we actually quite coincidentally started building power supplies for car audio presentations for companies such as Nagamichi and Alpine.
back then, ultimately at an incredibly low price compared to other providers, and extremely fast and reliable. And people all bought them to display in shops, to display at trade shows, because these power supplies were just extremely fast. They were regulated with only MOSFET output stages, very fast. The control circuit linearly regulated, and they had huge transformers and huge capacitor banks. Yes, and this MOSFET simply reacted and adjusted incredibly fast. This means at the very moment when a pulse truly required a lot of energy, it was instantly and directly available.
Yeah, yeah.
Yes, without anything breaking down. And that's why people also invested in these power supplies to showcase their power amps and other things, because it simply sounded audibly better. Yes, car audio always runs on a 12-volt system, so no dedicated power supply, but initially a 12-volt battery. And then for demonstrations at trade shows or elsewhere, this 12-volt battery must be replaced in that case by a power supply unit.
And the demo's success ultimately depended on how good the K-amp, K-Hi-Fi power amplifier was, that's clear. But it could only sound as good as the upstream power supply.
A power supply, right? Yes, I understand. It's logical without the... So it's an amplifier.
Exactly.
Yes, power. So current. And if the power supply doesn't deliver the current, then it can't amplify anything.
Yeah, right.
You had... obviously they got the ideal power supplies from you, and people heard that, but on battery it sounds just as good.
Yes, on battery it sounds just as good, but it was about demo situations at trade shows.
Yes, and then you have no battery left.
Or it'll just be empty pretty soon.
Yeah, right.
Given the requirements with the installations that went quite fast then, that's why we needed the power supplies, but it was absolutely crucial for the demonstration. You know, you simply need electricity, and quickly and without end.
That's awesome, yeah.
The car audio sector, it has changed a lot, but what has remained is the understanding no amplifier is better than the...
I think I read somewhere that for the year 2022, do you have anything planned? Any new things coming up?
Well, what's definitely coming for sure is that we'll be using our new alloys in many semi-finished products, but also in new products like smaller capacitors. So the audio chain has really changed, you know. Even there, if you're now moving towards mobile audio, you know, small devices like the size of a cell phone that power high quality headphones completely packed with components, right? For these types of SMD components and so on. At the moment, we don't have any, no
way.
Or small components where our material mix and our know-how is found within them, right? But that will certainly change in 2026, 2027. So, for example, many years ago, we would have already approached a laptop manufacturer who wanted to somehow upgrade his own, his audio part in the laptop. He would have loved to have Mundorf inside written on it, but our components were simply too big.
He heard that it's much better, yeah, but he naturally didn't put it in because here's a capacitor.
Yeah, you cannot.
No way.
Yes, not bad.
Not without somehow warping it first.
We must let it stick out, just like a tube amplifier.
Yes, exactly.
But then you wouldn't be able to close your laptop anymore. Yeah, exactly. And they would have liked that. And that idea just wouldn't let me go. So,
Your turn? Want to add more?
Yes, that.
Cool. Very cool. Wow, I find that wonderful.
And that's when doors also open up. I mean, years ago, I'd already seen videos of Yamaha synthesizers, the new, the very latest synthesizer. And they explicitly mentioned in the demo that at some point it has to go from digital back to analog before it becomes audible. That in the analog section they used particularly high quality components, passive components. And that's where I'd like to start, for example.
Cool. Yamaha makes good stuff, yes. That's Yamaha, yes.
That's in the where it becomes analog again on the circuit boards. That they do so, and there's now again
quality
with a Mundorf in it, all the know-how, all the substance that we previously
metal, an alloy that actually makes the sound much more beautiful.
Yes, and the design characteristics that can be transferred to that. Or for example, circuit board material from our patented copper alloys. Yes, something like that, right?
That would be ideal for us. for our specific projects. Yes, exactly.
That one,
well, it's only logical because it just has to. The sound actually travels through the circuit board. That's also a really, really old and ongoing topic. Point-to-point wiring versus a circuit board. You know, when we're talking about amplifiers specifically, right? Yeah. Well.
Just a quick question about the capacitors.
Yes. I just caught myself, but I didn't want to interrupt right now.
No.
If you can't find the exact capacitance value you need, but then let's say you purchase 2 or 3 and connect them in parallel, or however, does that make sense?
Yes.
Makes sense.
Yes, in case of doubt, by connecting them in parallel, you reduce the series inductance, the internal resistance of the capacitor, that is the ESR. That definitely makes sense. I mean, at some point, if of course the connection lines get so long, then it just eats up the benefit again. Yeah, but in a reasonable proportion, it certainly makes sense. So now, if you really want to take it to the extreme, you'd place 2 of them opposite each other, connect the ports twice, and then put them right in the middle.
Then shortest route.
Then you have the shortest path. So in the power supplies we built back then, there were always really thick copper bus bars inside, about 2-3 millimeters thick. Yes, it was just simply flat copper, and then it was bent. Yes, that was the internal wiring for all of the power supplies.
Cool.
There is enough metal grating for the structure.
Right. That's exactly the crystal lattice structure.
Well, I truly hope you all enjoyed this. Getting to see Raimund Mundorf and what exactly goes on inside the mind of this genius. And we want to sincerely thank you for your time.
It was very entertaining and witty.
And it was fun.
So, we're just swimming in good fortune.
Thanks a lot.
Yes, absolutely. Thank you for making the very long journey here.
For me, it was quite a distance.
That's really flown quickly.
Sure, if you're in the area, you can stop by and listen.
Off to Krefeld.
Cool. If you still have any questions, please feel free to leave them in the comments below, and we will try to ask them again and see what answers we can get. And yes, I hope you enjoyed it, and we'll see you in the next video. I wish you all the best. Bye bye.
Goodbye. Goodbye.
My leg. Oh.
It swings and vibrates. And then you also still have the microphonics. And it's simply the fact that when in a wire, in a conductor, the crystal lattice, he's referring to the crystal lattice, electrons move and collide with it. This means the crystal lattice is stimulated to vibrate. But now, because it is a crystal, the crystal lattice is electrically charged because there are free electrons. So the nuclei are now positively charged. So this is what we're seeing again. The moment the crystal lattice moves, it's like a small electrical current, isn't it? The positive atomic nucleus is shifted. This means microphony is created in the wire again. Yes, and I then played with that as a word pair, macromicrophony and micromicrophony, and then it also becomes clear because every crystal lattice vibrates differently simply due to its mechanical properties that different metals sound different. Yes, that's how simple it is in the end, and this oscillation is also known quite simply as the signal to noise ratio, you know, or in measurement technology, right? So when a crystal lattice, the conductor vibrates, it produces its own noise in the signal. And if I now want to measure something like brain waves or even smaller voltages, then at some point I have signals that are so small that they practically get lost in this noise from the crystal lattice.
We're almost talking quantum physics, but...
Yes, they're still in the middle, but then there are, because it's the next step, then you have these so-called monocrystalline cables, wires. That's where it gets truly outlandish. So when you're drawing the copper or the silver, it becomes a crystal. It's drawn in such a way that a crystal forms from the liquid metal with a homogeneous structure without any breaks, you see? And only then is it cut into slices. And the discs are then, for example, cut out with the laser in a spiral pattern. And then you end up with an elongated wire, which is not just a wire, but a crystal, truly a crystal.
It's absurd.
And that's because normally in a wire or a foil, you have many fractures in the crystal lattice structure from the rolling process, from the drawing, right? The crystal lattice gets really stressed and also deformed. That means the electrons are constantly colliding with some imperfections in the crystal lattice, and this causes the cable noise to increase, right? And these monocrystalline conductors are used everywhere where the goal is to have minimal cable noise.
Yes, that's why it's also used in measurement technology or in medical technology.
And I heard that myself. Someone at a trade show gave me a pair of headphones, a simple sound source, a cable, one monocrystal, one normal copper or silver, and he spoke with me. The music was always the same volume, and one time it was clearer to understand, one time it was harder to understand.
That one thing that made the difference wasn't the music, but that subtle hum from the cable in the background.
Yes,
That's what
exactly what you mean.
Yes, exactly. Interesting, yes.
Well, he demonstrated it to me at the trade show. There was no doubt. I was truly astonished. And that's when I understood our monocrystalline structure is just much, much less.
And that's what makes a good system in the end. If you later listen to a system and let's say you have some kind of effect, but it's not quite right, then for the first half hour you say, wow, cool, I've never heard that before. And after 3/4 of an hour you say, yeah, it's really great.
But hold on, I need a break.
Yes.
And if it's really true, then after 45 minutes you'll say, do you still have that track? I haven't heard it in ages. Do you still have that one?
Do you want to hear more now? You want to hear more.
And that's the point, because people always say, yes, Mr. Mundorf, your components, but I don't hear it anyway. That might be true.
All hear it.
Everyone hears it. And by the question, do I turn it off after 45 minutes or do I want to hear more music? Everyone can tell how the system's doing.
It is good now.
Yes, that's crazy, right?